Hello and welcome to the Global Passive House Showcase, presented by Passive House Accelerator, a catalyst of zero carbon building. We're happy you're here. We welcome all comers to our exploration of how to slash the greenhouse gas emissions from our buildings and make them more resilient to the extreme temperatures, the wild weather, and the grid insecurity caused by climate change. So, whether you're Passive House curious or Passive House expert, this is a place to learn the do's and don'ts, the best practices, and the lessons learned of Passive House design and construction. We'll dive into how Passive House design principles are applied in the real world and how this approach to construction impacts the health and happiness of the people who live and work in these buildings. Are you new to all of this? Visit the Passive House 101 section of our website to get started. With that, please enjoy the showcase and pose your questions in chat for the discussion session after the presentation. Thank you.
All right, everyone, welcome back to the Global Passive House Showcase. This is the 73rd episode, and we have a special guest host tonight. So here's Johnny.
Hello. That was a fantastic intro. I love the new look. It's good to be back. It's good to have this. I'm wearing my shirt, of course.
Very nice.
Yeah. So thank you. I'm Johnny Rezvani. I'm joining you from Boulder, Colorado, and I'm Director of Communications at 475 High Performance Building Supply, board member. Sorry. Sorry, I just ran across the room because I had to put my dog. I had to put my dog in the other room, and I'm out of breath. So that is why I'm out of breath. Full disclosure, that just happened because I couldn't hide it anymore. Okay.
That's awesome.
Director of Communications at 475 High Performance Building Supply, board member of Colorado Green Building Guild, member of Passive House Rocky Mountains. And on top of this being a fantastic and fascinating project that we're here to see tonight, it feels exceptionally appropriate for the times. I would turn my camera to show you Boulder's famous Flatiron Mountains, but you can't see them today because it's way too smoky. We have all the smoke coming in from the northwest and the west. Right now, none of that smoke is actually even coming from Colorado. And you'd think that, maybe if this happens enough and they can't sell condos based on their mountain views anymore, like we can kind of give a nudge to the real estate industry to sort of, make some more passive houses. I don't know, maybe it'll give us a boost. But so you're here tonight to see the Temporal.haus, which is a fully fleshed out idea experiment to achieve the most impressive, lowest carbon passive house premium design possible. This project was part of the 2021 European Cultural Center Venice Architectural Biennial. Its elastic support structure is anchored by a commissary kitchen and a street level porcelain tiled curved pavilion that will support the burgeoning food truck scene of Los Angeles. And so without further ado, tonight's presenter is Andrew Michler, originally from Oakland, California. Andrew found his way to the pine forests of Colorado Rockies, right up here, right up the road from me, where he's lived off-grid for the last 20 years. He's a certified Passive House consultant, member of Passive House Rocky Mountains, author of the book Hyperlocalization of Architecture, and designer and builder of the first certified international passive house in Colorado. And as somebody interested in the marketing side of things, I love to tell people that Andrew holds the distinct honor of having the most watched passive house tour video on YouTube. I just checked it. It's up to 1.6 million views. So Andrew, take it away.
Thanks, Johnny. That's thank you for the breathless announcement, breathless introduction. My first, at least. You all can see my screen. I'm staring at Johnny right now for some reason.
Not yet.
No, we
Not
can't
yet.
see your screen
Okay.
yet. Yep.
Not that you want to see me, but I can talk in the meantime.
We can see you, just not your presentation.
Okay, good. I'm just staring at somebody else. So yeah, so let me share my screen first. All right, guys. So let's go to Wilshire Avenue, or Wilshire Boulevard rather. Wilshire Boulevard is in Los Angeles, and this is where I decided to locate the project. It's a 7-story passive house, multifamily house. And I chose Los Angeles because it's an amazing city, but it needs a lot more housing and a lot larger housing. So there's an experiment on what a Los Angeles future building will look like. And so this one is right near Koreatown, near the metro station. I don't know if you're that familiar with Los Angeles, but it's a pretty interesting area, mostly parking around Wilshire. And also a fun fact about Wilshire, it's the original, what do they call it? It's the original, I'm trying to remember the name of it. Basically, strip mall, essentially. It was the invention of the modern strip mall. So we have that to thank for Los Angeles, if nothing else. And I was also really inspired by a trip to Kyoto, Japan, and how they dealt with housing in dense environments, especially with contemporary buildings, new buildings. And the idea of the shop house going back a couple of centuries, especially in Asian countries where often people would live in the upper stories or in the back of the building and make a living at the big front of the building. So you had this interaction with the sidewalk and community all through cities. So how did we revisit that? Well, the idea was the micro business. And I have a small coffee truck that I developed a few years ago. And the idea was how do you create micro businesses on the ground? And Los Angeles is quite famous for its mobile food scene. So the idea is to create a food park off of Wilshire Avenue where people can constantly come in, park daily rotation of different food trucks. There's a commissary kitchen on the ground floor and a bar, and just a place for people to congregate and get out of the sun and enjoy an afternoon lunch or even a dinner. And the upper parts are just living spaces for different types of different groups of people, from individuals to families. The biggest concern was that the site faces west in Los Angeles. So how does a passive house work when almost all your actual windows are going to be facing west? So we got very aggressive on the shading in that sense. The program is, the first floor is, as I mentioned, is some public utilities, restrooms, commissary kitchen, things like that. Second floor, classrooms and community room for the people who live there. And then various different types of scales of apartment buildings for families, individuals, couples, things like that. But one of the things we've been playing with was developing a, you can imagine a community space where there's a shared kitchen, so we can make the apartments a little bit smaller, a little less wasteful in redundant space, but also using the staircase and patios as community space as well. For fire escape is actually expanded out for more community use. The fabric of the building, and this is where a lot of people, most of the attention has been from folks, is this is going to be a wood timber podium, basically 3 stories, using CLTs and NLTs, cross-laminated and nail-laminated timbers, using wooden nails by a company called Lignolock. And then Echo Cocoon straw panels are the top 4 stories. Straw panels that are developed out in Europe, and they're getting quite well known, especially in Northern Europe. And they are a certified passive house component. And I'll get a little bit more into details on them. So the Echo Cocoon, usually the first question people have for these straw panels, they're not straw bale, they're straw packed, tightly packed panels. And the first people will say is they burn, but they actually don't burn. They're very high density, and which leaves no real room for oxygen for burning. And because it has a high content silica, the straw, that it's actually not that flammable in the first place. And we cover with fire-resistant materials, actually incredibly fire-resilient structural system and insulation system. The nails are wooden, developed a few years ago by Beck. Lignolock is the name of the brand. And they're developing cross-laminated and nail-laminated panels that you can make with automated systems without glues and things like that. So they've been busy developing robotic tables with pneumatic nail heads to create these large panels. So you don't need a large glue press to build them with. So smaller shops can build them. So it all comes down to the carbon question when it comes to the building itself. And in this case, the operational energy for the building and help with Passive House Institute is that we're running at 130 kilowatt hours per square meter in the negative. So we're producing much more power than we need, about 3 times through the Passive House Premium design process. And the materials embodied carbon, this is what the last thing I was able to get done before the show started, using the pH ribbon carbon calculator, is at 224 kilograms per square foot, per square meter. And it's hard to know what that really means because these numbers are pretty new, but this is a pretty low number. So I'll get into the details on what that actually means and some of the caveats involved. Quickly, the solar panels. The solar panels it's a huge array on the building. One's a horizontal, one's a vertical. And I'm showing the graph for the PV output because in the winter, when we need most of our demand and the lower production, typically for solar panels, the horizontal panels, the vertical panels work almost as well as the horizontal panels in that configuration. So, it's about time of use and time of making power throughout annual basis and also on the monthly basis. So it's good to keep that in mind when we're designing these not net zero energy buildings, but these real-time energy buildings. Passive House verification. So we're able to almost completely eliminate space heating, have a very tiny heating load, and most of it's space cooling. So we're about 2/3 of the cooling demand threshold for Passive House, which is great. So we did get cooling under control in Los Angeles. And with the PV and doing some things like the triple pane windows really actually made a big difference, as well as doing heat recovery for the hot water, things like that, really just edged us right over to the premium part of the chart, which took quite a bit of work, but it was fun to see that actually doable, at least theoretically. Part of the systems that we're using, I mentioned the triple pane windows that made a big difference. The double panes actually gave us more of a heating load, which would have complicated the entire system. So it may save us money in the long run to put triple panes in rather than double panes, as well as the comfort and energy savings. We can combine the cooling with the ventilation system, like using the Ventacity system, HRV on each floor, coupled with a heat pump, VRFM or type of system. It looks like we can get trickle cooling to each floor or to each room based on each floor. And we're using basically the space behind the elevator shaft for the equipment, so it can get nice and compact and right in the center of the building for easy distribution. On the carbon side, I was using, as I mentioned, the pH ribbon, which is just being released. It's in beta now in the United States. It's out in Europe on the metric, and I was using the metric version of it. But they'll be rolling out the Americanized version of it pretty soon. Hopefully, we'll see in September, maybe not. And what I was learning with the ribbon, it's a PHPP plugin, and I can take all my takeoffs from the building and then assign what the materials are. And a lot of those materials are actually in the library itself, so it's pretty easy to match it with the wall assemblies, floor assemblies, roof assemblies. And what you can see is that PV is actually the largest single carbon embodied material or category within it. And part of the reason is because the PV needs to be replaced every 25 to 30 years, is the assumption. So each time that gets replaced, we make a big tick up in the carbon. Same you could say for batteries or other kind of energy producing and storage equipment. Outside of that, windows get replaced every 50 years is the assumption. The timber storage is, of course, the biggest part. So the fabric of the building, the podium of the building is the storage. But that is also with the assumption that when this building's taken apart, it's not thrown into a landfill, but being reused. If it is thrown into a landfill or burned, most of that timber storage within the calculator gets thrown back into the atmosphere. So it's not necessarily long-term embodied carbon, but a carbon emission source. So to me, it speaks about you need to design the building as much for deconstruction as for construction when you look at the embodied carbon aspect of it. So lots of stories there. The real story is, yes, we can get near carbon buildings, but once you get to these really low numbers, your energy production can offset whatever you're storing in the building. So we're still way off from the true net zero carbon building, at least in any kind of scale. And just a quick shout out, I'm going to give a further, much longer detail talk about an hour and a half with somebody from the Passive House Institute, Bjorn Kjell from Echo Cocoon, and the developer of the Lego Lock Wood and Nails on October 29th, hosted by the European Cultural Center. So thanks for your time. Thanks for your patience, guys. Back to our regular programming.
Well, excellent. Thank you very much, Andrew. We're going to go over to Zach quickly. Zach, over to you.
Right, awesome. Thank you. Well, I want to do a quick thank you to the sponsors that make all of our programming possible here at the Passive House Accelerator. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxtingwe Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool North America, StoCorp, and Zola Windows. Thank you also to our champion sponsor, SIGA, and to our stakeholder partner, NYSERDA, the New York State Energy Research Development Authority. And thank you to our patron sponsors, AeroBarrier, BR+A Consulting Engineers, Brennan Air Tightness and Installation, Innotech Windows and Doors, Sanderson Sustainable Design, and US Engineered Wood, T-Stud. Thanks, everybody.
Thanks, Zach. And Johnny, you had a couple of comments you want to add before we go to questions. So I'm going to throw it over to you.
Yeah, I mean, one of the things I can speak to, and I was interested in seeing, I noticed some of you commented on, was the Eco Cocoon panels going multiple stories high. I had the pleasure of actually getting to see these in person. If you go to 475's blog, you can find, we did a show with the Discovery show Building Off the Grid. They used Eco Cocoon panels and Proclima membranes to make a very high performance, low carbon house in upstate New York. And I was there for the filming. And seeing those panels in person was really remarkable. They took, it truly elevated straw to a high performance material in a way that I was not even expecting was possible. One of the things that really struck me is we were trying to put a hole in through the wall for Lunos. We're installing Lunos, and we're just pulling and pulling and pulling that straw, and we would pull for a minute straight, and there was just you couldn't even tell where we were pulling from. Like, it was just this infinite loop of straw that was, and we ended up having to cut through and once we did, it completely held the shape like it was wood. It was like a solid object, and yet it was just straw. We also did some just sort of field tests around some of the things that people generally worry about these, but really truly remarkable thing, and would love to see one of the comments we had yesterday when we were talking about this was, if we could see something like this made right in the middle of Kansas, it would just be a game changer for the US market in particular. But yeah, otherwise also just would just love to see this project happen. Very cool.
Yeah, I have Johnny. I see already a couple of people are asking questions about it. I have the PDF that has the up to 5-story structural assumptions that go through shear and load sharing, all that good stuff for the wall system. It's pretty intriguing.
Well, on that point, let's dive into the questions. So actually, Lloyd had a different question to kick it off. And so Lloyd, I see your window's off. So he was wondering about who's going to Germany for the conference. So but I cut you off, Lloyd. Did you have anything, other comments before we dive into the questions for Andrew?
Well, I apologize for doing that in the first place, just at the second you were getting onto this. But I was, I really wanted to go to Wuppertal, but it was just not going to be possible, especially when I'm monitoring my carbon footprint. But I was shocked to get the email this morning to see that they've just canceled all of the live in Wuppertal stuff, and was wondering if anyone had bought plane tickets and was suddenly not able to go. And just curious, among this passive crowd, I know Mike Ingwe never misses these conferences. Does this affect him or anyone?
Yeah, it freed up my week, Lloyd.
Well,
a lot
Did
more
you have
flexible.
tickets?
My wife is very happy.
Did you have tickets?
Sure, yeah. The
Well,
hotel tickets, the whole 9 yards.
well, hopefully Ken and everyone
Meetings.
else, you guys can get refunds. But that just means that next week we're all going to be up in the middle of the night watching it all together. And I'm sure with the Discord, we can actually join, and we can have a Discord channel for all the ones drinking coffee and watching it. So we'll just wait. We'll set that up.
That's a great idea. I'll finally actually get to use the Discord thing. That's
Yes.
a fabulous idea to focus on this. I'm so disappointed in this not being able, that it isn't happening live.
Yeah.
So
And to clarify, the program is still happening. It's just online only. Yeah.
Yeah.
So Andrew, we had some really good questions, and we're going to start off with Tim Keating. So Tim Keating, you had a couple of comments, and let's get it started with you, Tim.
Oh, hi. My first time on one of these with you guys, so thanks for that. Yeah, I just was kind of making a point, and this is a point that I've been making everywhere I get a chance to, that the LCAs that are used to come up with numbers for the embodied carbon of materials are, when it comes to wood, every single one of them, if you look at their methodology, they assume that the timber is harvested sustainably. And so right off the bat, really what they're doing is excluding any variables that have to do with the forest ecosystem. And so all of the carbon is basically considered emissions of the equipment and things like that. So in terms of the losses of carbon that have to do with the management and the harvesting of the trees, that's actually, when it comes to these LCAs, that's kind of an externality. And so that's why they can end up with this, what is now gone kind of viral, this sense that harvested wood products are, embodied carbon friendly. So unfortunately, I've been working to stop people using tropical hardwoods for over 30 years now. And it's the worst of the worst, but the more I look into plantations, all the science actually shows that older forests are way, way better at absorbing carbon than young forests. And when it's plantation management, like 25-year rotation cycles and whatnot, it's actually almost zero benefit whatsoever. So that's where all the CLT is coming from, unfortunately.
And Tim, just to clarify, where are you from?
I run a company called Earth Built. I actually consult on sustainable wood, but I ran an environmental group for over 25 years called Rainforest Relief.
Gotcha. Great. And just so we can help each other out, because we'll get into a break room later, is in your name, everyone, like you see, it says Sean at Vancouver. Throw where you're located. So we'll get there. Tim, really good point. And this is, I mean, we can get to a whole conversation between plantation and cutting 80s and ancient forest, but really good points on that. Andrew, do you have any comments on that point?
Well, I think the first point is if I think that's a really important point. When I wrote my book, Hyperlocalization of Architecture, kind of in the early days, I did a Cascadia harvest chapter on kind of what people were doing up in Vancouver and Seattle around right when this mass timber thing started taking off. And definitely the thought is like, don't just throw wood in willy-nilly, mindlessly, and using it as a carbon sink as an excuse. Like use it resourcefully, use it rather than concrete and steel, of course. But don't use it as a crutch for your carbon goals, certainly. And that's why I like the Eco Cocoon panel is really interesting, because it's using standard 2x materials. So it's using wood quite judiciously in this case. So, it's definitely where you need a podium, where you need kind of a base structure. We need something besides concrete. Use wood there where it works best. The Eco Cocoon panels, where we're using more of a standard 2x material and much less wood, use it there. And again, it's the reuse factor, which is just as big. And Lloyd wrote about it. He was talking about his coffee table being from a bowling alley. It's like we should make our buildings so they're reusable over and over again. And the old mass timber buildings were fantastic at that. So, kind of developing that cradle to cradle type of thinking is more important than trying to do carbon offsets, totally in my mind. So yeah, I agree with you. The science is very complex, too complex for a building designer or for a spreadsheet.
No, good stuff, Andrew and Tim. And again, if you guys are looking for some CLT manufacturers that are doing a good job, you have Kliznikov that just started their factory 8 months in BC, and they are probably like a European model where the great grandfather was in forestry, the next kid started the forestry side, and now the grandson is starting an added value, and they actually use FSC lumber. And then Mark, you have another good company in Montana that I'm totally forgetting, and hit me with it. It is, unmute yourself and say the name. Starts with a V.
Are you talking Vaughan Timbers?
Thank you very much, Mark. Thank you very much. Okay, thanks, gentlemen. The next question is over to Kevin Brown.
There we go, unmute. Yeah, I was just wondering what, it has to do with the sustainability of the timber products, but what was your assumption for the longevity of the building? How many years would you say?
So the standard, so this is using the RIBAs because this is a English-based calculator, at least the one that I was using, and they use a standard 60-year, which is pretty low. It's called Temporal.haus. I have a 250-year life assumption with it, and that's very much if the program can be changed over time. That's not if like the apartment walls can be taken out and not affect the structure of the building, so we can use it for offices or whatever types of uses in the future. But a beautiful, well-loved building is, some people say a loved building is the most sustainable building. So that's the viewpoint in this. And of course, it's passive house, right? You don't want to tear a passive house down.
Yeah, and the one thing I've noticed is that when we look at the level of quality control and the care with which we take to build these buildings, they're simply got to last longer. I mean, just have to,
Yeah.
So yeah, that's great. Thank you.
Thanks, Kevin. And next time you're in Vancouver, there is a mass timber building that is 9 stories that is now 110 years old, and it now has a brewery in the basement. So just saying, it's a good thing to do with an old wood building. We're over to Yasha Org.
It's Yasha Og.
Sorry, thanks.
That's fine. I think my question also covers questions from Scott and Lance, and it's related to structural components of the EcoCocon walls. So I looked into them for a small project that was 1 story, and I ran into concerns from my structural engineer on wind shear and seismic and various other structural things I don't know how to calculate. And he wouldn't sign off on it, which is why we then started looking into other solutions for our project. And so I'm wondering, how are you navigating both the codes for using this as well as the structural component holding up 4 floors of it?
So structural engineers have their own language and their own needs and desires that are not necessarily in correlation with my needs and desires often. So the first thing I do is find the right structural engineer. And that means that somebody who's willing to do something that he hasn't seen before. So, that's the first thing. And he may be right or he may be wrong, but a good structural engineer, if the EcoCocoon panels have done stress testing and make sense, then we have to find a structural engineer who can work with that. You can always put a shear wall. You can put plywood on top of the face of this stuff for shear, for instance. And they're sharing the structure load with the internal wall as well. So the load bearing is both on the external and an internal wall that acts as shear. So it's sharing those two things. Wood is incredible stuff. How many times do you see an old wood building that was never engineered actually collapse from wind or snow? You almost never do. We don't trust wood enough, I feel personally. So I'd like to go back to the place where we don't talk about our embodied carbon. We're over designing buildings so much that we're sinking, half of the carbon is a foundation that probably won't ever, is twice as built often as it needs to be. Maybe we're putting twice as much wood inside of the building that we really need to be because of some of these assumed assumptions. Then we get hurricanes and big earthquakes than we ever assumed too. But we need to find people who can make those balances work in the real world and are willing to try something new. But there's plenty of these buildings in Europe. So.
And then I guess, how do you go through with the code process, like code review of getting it built in California?
That's a good question. I don't know the answer.
Okay.
It's a hypothetical, This is a dream project, right?
Okay.
But I think it can get done. It can get done with the right people and the right kind of attitude. And basically, we're looking at, so the code we're using is the new IECC mass timber building code. It allows up to 8 stories, 85 feet. 9 stories, 85 feet as a timber light frame building. So the code's there for these types of buildings. So then it's more about the structural engineer approving the particular timber framing construction for the job. So it is codified presently.
And that's a good thing you brought that up, Andrew, because Cincinnati actually has the tallest mass timber building currently before Milwaukee takes it over next year. So we're starting to see big mass timber buildings, which is exciting.
Yeah, and shout out to the folks who really pushed this within the IECC code. They really did an amazing job of getting mass timber or timber buildings that are taller than just 7 stories or 5 stories into code. So that's a huge leap.
Sean, did you say Cincinnati, or what was the city you said?
It's in Cincinnati. I know because friend Ralph from Seagate Structures was there, and because I think all the CLT came from Structureland, if I recall. But I'll find it out for you because I'm sure you'll be surprised. But it's in your backyard. You might have to go do a tour of it for us. It's not passive, but it's mass timber.
Sean, it's Cleveland.
Oh, it was a C word. I thought, I was trying to make a connection to him. Totally way off.
No worries.
And
the timbers from Bender in Austria. And you're right, Ralph assembled it with a local union crew. I was there to watch him do it for a little bit. And
Perfect.
it is, you're right, it's the biggest building, tallest building in America so far until Milwaukee comes. Mass timber building.
Thanks, Jeff, correcting me. And you know what? I actually just do that. I just say random stuff and wait for you to correct me, folks. I just wait for it. No. Thanks, guys. I was trying to get close to what we're on to. Okay, now we're going to head over to Graham Urban. Graham?
Hey, first of all, Andrew, I love the project. Really nice work. That's a preamble to this. I'm a little triggered by this whole thing, and Zach knows because I was on a text rant with him about, I think it was it 12,000 or 15,000 square foot single family residence, Zach, that they were getting certification and touting that it was carbon negative. And I guess I'm just wondering in general about the rationale. I get that this whole system causes far less harm, but to me, the thought experiment, if something's carbon negative, that would mean the more of it you do, the better off the planet is. So I don't get the justification, like how cutting those trees down reduces the carbon in the universe. I'm talking about that negative carbon factor. So that's just a maybe misplaced question. But
well, I mean, I live in a forest. I live in a county where probably 40% of our forest is burned from 2 fires either last year or 10 years ago. We have a lot of timber. Timber is just about one of the most efficient ways to sequester atmospheric carbon that can be turned into a manufactured product that we know of right now. So it's a cycle, you know, it's a complicated cycle, and a lot of people created carbon offsets by planting trees, and those forests are burning right now in California. So, you know, it's not the end all be all, but we're just using the carbon calculation. We're not talking about this land stewardship or habitat protection or longevity, right? So that's just one number amongst a whole bunch of other environmental priorities. And it can be confusing. Sure, the building could hypothetically be carbon negative, but that's not necessarily an environmental positive if we're strip mining our landscape. So yeah, it's keeping that in perspective. But at the same time, you know, I have billions of board feet of ponderosa pine and lodgepole pine that's going to rot in my backyard, and it's not going to grow back anytime soon. So, you know, we have to figure out some way to be able to mindfully use this. The woods that I live in are 90% overgrown from lack of forest stewardship for the last 100 years that was of white people suppressing forest fires. So now we have forests that are completely choked in Colorado with timber as well. But, you know, every time we have the federal government do it, they just do a land giveaway and create these massive dead zones, it's the timber companies that create these big dead zones. So this is the question needs to be, this is something that we need to keep questioning and going back to, for sure. I'm not here to defend any particular point of view, but you know, I'm not going to be using concrete or steel. I know that.
I think Graham is happy with that, so we'll keep going on.
Yeah, okay, thank you.
Or Graham, was there any other comments you wanted to add?
Like we have cork behind you, Graham. See those cork samples? Like, I think that's the ultimate way to harvest sustainably wood product. But we're not growing cork trees. There's hardly any market for it. So, you know, it's.
Andrew, can we just move on by just saying good, better, and best practices?
Yeah, that's right.
Perfect. All right. We'll go over to Scott Kennedy.
Less worse than most is worse.
Yes. Scott, far away.
Oh, hey, Andrew, good to see you again.
Hey, Scott.
So my question was really related to structural shear, but it sort of leads into other interesting questions. I understand the issue. I was just wondering whether if they've done some testing on the panels to actually confirm what I suspect, is that the straw actually adds a significant amount of strength to the panels, way in addition to the wood, particularly in shear. Have they done any kind of tests on that? I assume they have.
Yeah, I think they have. And I think what they did was they did like real tests where they put weights on it. They stack the buildings and put them on shake. I think they did put on a shake table. And so I have that PDF. I don't think it's on their website right now, or you can go to Echo Cocoon's website. They actually have a lot of PDF resources there. They might have the multi-story PDF there. If not, just email me and I'll send you my copy.
Perfect. So I guess the other question is, in terms of the cost of these panels versus other options that we would have, which would be, I don't know, an I-joist with blown cellulose or something like that. Where did you ever get any idea where the cost of these things would be?
I think it'll be comparable to what a typical prefab panel is.
Okay.
What we're getting in the States. The caveat is that it's extremely labor intensive because they're hand packing that straw because it's just going in one direction. So they're taking the bales apart, taking the straw and hand packing it. And they're trying to automate that. Bjorn's been talking about that for quite a while, especially if they're going to create they want to localize it and create factories so they kind of do more automation. So right now they're just made in place, Eastern Europe where the labor costs are low.
Thanks. Your comment about thinning the forest leads me to, if anybody's watched Clarkson's Farm, Jeremy Clarkson's Amazon special, which is a hoot and well worth watching. As funny as it sounds, but he was thinning his forest out and getting all concerned about the environmental people, even though the whole point was to thin out the forest and get the forest floor. Anyways, thanks. Good to see you.
Yeah, you too.
Excellent. Thanks, Scott and Andrew. So now, we typically, in the past, we do breakout rooms at the beginning, but we thought we'd have such a great discussion. We build up all this pent up energy. So then now when we go to breakout rooms, we'd have lots to share. So Zach, are you ready to send us off into breakout rooms?
Yeah, you bet. Let's see here.
So as we would do before, say hello to your guests in the breakout room, and there's lots to discuss.
All right, I think everybody's back. So I want to say a big thank you to Andrew for this great presentation, as well as to Johnny for guest hosting the inaugural episode of the Global Passive House Showcase. I'd like to make a couple of really brief announcements about upcoming events. So I'm going to do that now. Next week, we launch the September Passive House Accelerator Construction Tech. So the first episode of September, and it's back to school, which is appropriate. We're kicking off the new season at BCIT Building Science Lab. So join us on Tuesday for that at the regular time. And then next week, our Global Passive House Showcase will be a special edition. So every month, one of the showcases for every month will be based in the UK or in Europe. And we will do the showcase at this earlier time slot. So at 11 a.m. Pacific, 2 p.m. Eastern, 7 p.m. in London and in Dublin. So it's a time that is more sane for our friends and colleagues in the UK and in Europe, and hopefully at some point in Africa as well, in that whole set of time zones there. So please join us next week on Wednesday, earlier in the day, for this great presentation by Anne-Marie Fallon of Archetype about Passive House schools. And she's going to be talking about design details, as well as the experience for students and teachers in these buildings, and implications around COVID as well. Really super interesting. And then we talked about this already, but we've got the International Passive House Conference starting next week, and it will be all online now due to COVID stuff. So all of us get to enjoy the full experience with everybody else around the world, and we hope you'll enjoy that.